So from this point onwards, we are going live on YouTube, sir.
Okay.
So with your
Okay.
kind permission, should we start now, sir?
We can start, but I would
Yeah,
sincerely urge, let's wait for 2 more minutes. Let's
yeah,
see
oh,
if
it's
people
okay,
are
it's
joining.
okay.
So let's start by 2:10 because I don't have a lot of things to discuss because this is a
Sure, no
very
worries.
knowledgeable forum. I think the most knowledgeable forum because even in our organization also you will find rare PhDs, rare lot of guys are like they're just college pass outs, so they are
Yeah.
getting matured in their journey day by day, year by year. But yeah, this is a great audience, I would say. So so please forgive me if I say something that I should not say, right?
No, sir, it's an open forum with all the
Okay.
people, open-minded people here.
Okay. And for the undergraduates also, like who are pursuing BTech, please stop me in between, or you can type in chat. Or is there anybody who is monitoring the chat windows also for questions and all?
Yeah, I'll be doing that for you, sir.
Okay.
I'll be doing that for you, and people are not allowed to actually mute or unmute themselves. They will remain muted,
Okay.
and
Okay.
they will be communicating through the chat window only.
Okay. So I think we can start,
So
sir.
first, I'll be
Right.
introducing you. So
Okay.
a very good afternoon to one and all present here. As you know that this is the fourth version of this international FDP, which is going on in online mode and themed on recent advances in computer science and allied domains. And as you can see that we are now drawing towards the end of this FDP. This is our second last day of this FDP and 10th technical session in this FDP. So today we have with us Mr. Ajit Tripathi, who is working with Microsoft Hyderabad. So Ajit is having around 13 years of professional experience working with several MNCs like Microsoft, Cisco, etc., to name a few. He has worked in various domains like networking, ad tech, search space, and CRM. He has exposure of diverse technological areas from highly transactional systems to compute heavy systems to pure enterprise systems. He is currently working as senior software engineer with Microsoft Hyderabad on products which are impacting billions of users. As an experienced technical lead with a demonstrated history in creating an edtech platform to handle billions of requests a day, creating a search platform of terabyte scale, he is also a strong engineering professional skilled in Java, C, algorithm design, data structures, concurrent programming. He has been a brilliant student throughout his academics and is still in the habit of reading books. As you could see that he has yesterday only he has ordered 4 books and you can see the library behind him. So with these words, may I now request Mr. Ajit Tripathi to kindly take over and address the gathering. Over to you, sir.
Uh, Thanks, Arun, sir. I
My
thanks for
pleasure,
the
sir.
kind words. So, so, so I am not actually I have not thought about like what needs to be discussed here, but definitely let me start with my personal experience so that because it's a open forum and sir, there are other branch students also there in
Yes,
this
sir. Yes,
discussion.
sir.
Okay. Okay. So I will try to be very much branch neutral in my discussion. That's how the industry is also like they are not very much focused about whether you are computer science student or a IT or say mechanical electronic because it's the engineering by nature. That's what they are looking for. What an engineer is like they are logical. They can make something to have a predictable outcome, right? That is what an engineer is, right? So this talk is going to be very much engineering branch neutral per se, I would say. So let me share my experience as Arun sir has already shared about my experience. So I have worked on. He has rightly said that I have worked on companies like Cisco and some startups. Right now, I'm working for Microsoft since last 5 and 6 years. So what sir has said about the transactional to compute heavy system, I will try to make this term clear because I want to at least make sense about the profile that Arun sir has shared. So transactional system means a system which is capable of handling billions of requests a day, right? So billions of requests means if you can understand like when your system is up on the production, people from across the planet can hit your servers and they can get the information that they want, right? So that is the definition of a transactional system. Now, a compute heavy system, if you would like to understand, the compute heavy system is a system where CPU is running very high. Like most of the folks here are, I think they must be teaching operating system also. So in operating system, we typically talk about two different processes. One is a compute heavy process, one is a IO heavy process. So a compute heavy process is something where your CPU has to run, definitely. Your task has to complete, irrespective of scheduling or multitasking you are going to do inside your operating system. One has to come do the heavy lifting, right? So that is the job of a compute heavy system. Like if you build a search platform, then what will happen? You have to process millions of documents, right? You have to process them, you have to index them, you have to store them so that they can be queried in a very, you can say, sub-second latency time frame. That is what is the definition of a compute heavy system. So I will not overload everyone with the highly technical and this kind of discussions. I will start slow and let's see if because this is a forum for engineers or who are going to be engineers also, like call students also. Like I want to give you a direction, like what needs to be done, like to be a successful. I am not considering myself as successful, just to tell you. I'm just telling you what needs to be done, right? The point is be sincere in your college itself or remain sincere throughout your life, because the that is the dilemma I am going through, right? I was not a very sincere student in my college. So the side effect of that is I'm still ordering books. So a choice is yours, right? Which way you want to go. So let me share my screen. I have prepared only a couple of slides. I will talk more, and I will sincerely request to people to ask questions, and let's make this system more engaging, right? So let me know, sir, if you can share my screen. If you can
Yes,
see
sir.
my screen, I would.
Yes, sir. Just go in slideshow mode. Just go in
Okay,
slideshow
yeah.
mode.
So what
Visible now.
visible, right? So this is a quote that I have, you can say, copied from some talented guy. He says that the capacity to learn is a gift, and ability to learn is a skill, and willingness to learn is a choice, right? So I found it very interesting, and I thought it's very contextual for this discussion. So it's like, for me, I don't know which bucket I will fit into, but I love learning. I want to learn, I think, a couple of pages on a daily basis. So that's why I am very much into this, very much big fan of learning methodology, new books, and a lot of things, right? Even just to tell you that in Microsoft also, there are a lot of guys who are working in Microsoft whose books are being taught in universities, right? One is Eric Gama. You must have heard about him. Eric Gama is a pioneer in object-oriented analysis and design. So if you have heard about Gang of Four, right? The four people who have defined how object-oriented and reusable software can be written. So Eric Gama was one of them. There is one book of database. Uh, if I remember roughly, it is Database Management Concepts, written by Raghu Ramakrishnan, and there is one Johansson Geherke kind of. Excuse me for my mispronunciation if that is. So though these are the folks who are actually working in Microsoft, right? They are just a ping away from anybody who is who is working for Microsoft. So I would say that these are the guys who are in their 60s, or few of them are in their 70s also. But still, they can code like a, you can say it's a fresh college grad, right? They can code day in and day night throughout the day. They can code. If you request a code review with them, you ask them to review your code, they can give you thousands of comments with a for a just you have written 20 lines, right? You have written 20 lines of code and you can expect 1,000 comments from them, because that's how the thing is. So why I'm emphasizing on this piece, because you can do wonders with this skill, like the one word that is learning, right? Be aggressive, be thoughtful what you want to learn, and lay a plan like how you want to learn, right? And the best time to learn is your college only, right? Or people say that anytime you can learn, But if you want to optimize your journey, then start early. That's what I want to say. Now, let's go to these things. These are also a magic life. These are not written somewhere, but I think, what is the importance of software? So if any time, if I talk about computer science branch, just stop me and tell me that you said that you will not discuss about any branch specific thing. You will talk about all the abstractions, right? So what are the magic lines nowadays, right? If you see, our society runs on software, right? Nothing happens in the society without software. Name me anything which you can done without software. Whether we want to buy something, you want to sell something, you want to go somewhere. Even the irony is we are communicating through a software. Someone is streaming our video and pushing to their servers, and that is live streamed across different feeds, right? There is one YouTube channel also you have shared with YouTube also. There is also software, right? You shared it. Now these video streams are streamed towards YouTube channel also, and now they are they are tagging all the video frames corresponding to a particular video ID, right? That's how the thing is. You can't think anything. You can't think of a simple system like from AC to your car to your name a few like microwave, whatever it is. Everything runs on software, right? So the importance of software, I think it is not required to talk about that. It is not 1960s or 70s. Everybody knows about software. Even in 60s, 70s, people who understood the importance of software, everybody is billionaire, right? So in that time frame, if someone would have thought about like I will build a software company, people would have laughed at them, right? They said, "Hey, he is not in a good shape of mind. Let's do something else. Let's build iron. Let's build heavy duty or something else." See where people like Bill Gates and this Jeff Bezos, they are early starter, right? So one key takeaway is you start early, right? I'm a big fan of sports fraternity also. If you talk about all the sports personalities who are milestones, who have set up a milestone like Sachin Tendulkar or say anybody, right? They started early. They identified like which is their area of interest, where they can create most, they can be most impactful, right? So same key here. Everybody is special. Just you have to find when to start, what to start, and how to start, right? So that is the that this slide is dedicated towards importance of the software. And I have taken name of some fancy guys who are billionaires just to make you understand exactly how people have achieved milestones, how they have done wonders. Like if you talk about even we study about a Morris Meno book, right? If I remember correctly, Arun sir, I think we study a book of data something organization, right? Digital design kind of thing, right? That fellow is also a billionaire. I think he is the founder of Intel or something of that thing. So all the computer scientists, like if you talk about Dijkstra, if you talk about this Tenenbaum, if you talk about these, all the Tony Hoyer, I think who has created Quicksort, they all are billionaires. And how they became there, only the learning is something that took them to that place, right? They are from a very humble background, but they knew the importance of software at the very early stage. Now, the next thing is who will write the software, right? I am writing a software and you will write the software. People from academics also, like if you are a PhD student, if you're doing your master's also, software is the way ahead, right? You have to do simulations, right? What is simulation, right? The simulation, as I understood, the simulation is you have suggested a technological improvement, right, in a significant area. Now you have to do it. There is a proper fancy term that calls reduction to practice. It's not like you will say that I will write a software that will take your aircraft from India to San Francisco in 5 hours. That's not that's only hypothesis, right? You have to, in order to prove that your hypothesis is correct, what you have to do, you have to do due diligence, you have to do some experimentation, right? That's what the thesis is. Right now in computer science, or even I have friends from mechanical background also, they are also doing some CAD and other stuff so that they can simulate the stuff, right? So who will write the software? So as I said, right, the critical part is everything runs on software. Second part, there is a demand. right? There is a demand that software is required. Who is the supply? Supply is us, right? We are the one who can master a programming language, master a design or anything, say big data, AI, ML, and they can start writing the software. And these days, people should not be company bound, right? You don't have to be part of Microsoft, Google, Amazon to write a good quality software or make an impact in the industry and become, you can say, improve this fraternity, computer science, right? What you can do, the piece is there are open source projects also. You can go and contribute to open source projects, write your own operating system, write your own simulator, right? These are the things you can do. So the thing is, I have talked a lot of big things, big names and fancy stuff, right? The key is to start small, right? That's what the key is. Now, I have talked about a fancy name learning, that is the DNA, that is, you can say, blood or say vessel, whatever you can call it, right? I discussed about demand. I discussed about supply. How can you become a potential supply so that you can target that demand, right? That's where the importance of engineering comes into picture, right? So the key is you have to start early. So start early means it can be you are in 8th standard or in 12th standard, or you just forget about it. People from UP board also definitely in this call. So UP board doesn't teach you computer science. I don't know whether they have revised their curriculum, but there is no computer science, right? But even if you start in your first year of college or second year of college, the time is sufficient, right? People might have question like, I don't have any computer background. How can I start? I don't find computer interesting, right? So what you have to do is start writing simple programs, right? Because computer is something that is a dumb box, and language is something that will enable you to talk to your computer. You can talk to your computer. The vehicle is the language, right? He will not understand our, even these days people are working towards like you can tell and computer can program, but still that's a 50 say 100 years away. You can talk, you can tell that build a system that can handle billions of requests a day and it is 5 nines of availability, right? So start early, start making small programs. So a small program means try writing a factorial program, start printing those fancy triangles which we used to do in our college days, like draw that right angle triangle, draw a equilateral triangle. That's a smallest program. Start from hello world, right? I don't have a concrete answer to the fact that why your first program is hello world, but based on my understanding, hello world is basically you can say a birth of a programming language or birth of your programming brain. You can say that just a print message saying that hello world, I am there. So it's like hello world, this is hello world, right? So I don't know why they named it hello world, why hello world is very popular. There can be reason where, because the C programming language or assembly language, they have started with hello world, that's why everybody is calling hello world. But this is my interpretation. So make your own interpretations. Start small, try writing small programs, take help of your teachers, your mentors, your college seniors, or your group also. Sometimes in a particular group, people who are not good at curriculum, they don't have a very solid background, they don't have a very good rank in their UP seat or say AI but still they are a great programmer, right? Because they can focus on one thing, they can't focus on hundreds of things, but they can focus on one thing, that is programming, right? And if you tell someone like write a program and it can, you can you can get a very fancy job that is very much respected in our college, like our super seniors got placed in this company. So that's what the motivation behind someone starting the programming and all, right? So my takeaway or my suggestion is to start early, start small. Don't think about building a robot who can do anything, who can just take you, who can book your Uber. You just say that, like if I don't know how many of you are Marvel fans, the way Tony Stark is there in the Iron Man movie, right? He can make his robot do anything he wants, right? He can simply clap and say that Jarvis do this, Jarvis book my flight, Jarvis do this, Jarvis analyze this person's pattern, like what kind of terrorist he is. So that's not how the things are. But start small. See, when you will start, you will first time the program will not compile even, right? But you will understand why it has not compiled. There is no problem in compiler. It's the problem in your code only, right? Start small. Give 6 months to your career just to write small programs. Like if someone will tell you, okay, write a factorial program, you should be able to write it in 5 minutes, right? Just write it. Then there comes a complexities, right? Now start thinking about you have written factorial using a recursive routine. Now become critical, be critical, and be analytical. Think like factorial is factorial n equal to n into factorial n minus 1. That's it, right? Which is a recursive call. N is calling n minus 1 till, and there is a terminal state till the point it hits 1, right? This is how you have written the program. You are happy about it. Think from the perspective of processor. Be the computer. Like how computer does that? Every function call is pushing set of arguments to a program stack again and again, right? Then when you are returning, it is traveling backward, right? Then you will understand, oh, this is a costly routine, right? Can we optimize it? I will come to that part later. That's a part of this agenda. But start small. That's the key of this. So I will stop here, and there are only 2-3 more slides which we will discuss in detail. But let me know if anybody has any question here. I would like to love to answer.
Audience, if you have any questions, you can write down in the chat window. If anybody has any question.
Okay, no problem.
I think no questions so far.
So no problem, sir. Question. I think these are very obvious things what I am talking about.
The
That's all.
motivational kind of thing is there.
These are the only obvious things that I am talking about. And just like from the teaching community, I will also urge, like, don't push a candidate, or don't, like, the curriculum. What curriculum says that? I have seen the curriculum. I have been part of that curriculum. I studied that same syllabus, right? The syllabus is very carefully designed, right? If you see entire computer science, if you talk about a single company like say Amazon or Microsoft or Google, they are working on almost all the topics of computer science, right? Be it database, be it algorithm, be it data structure, be it AI, ML, everything, right? So what my request is to engage with the students and just start enabling them to write simple programs. Don't just push them, like write a big software, right? Who can handle million of transaction in a day, just like Make My Trip does, right? It's not possible, and it will only confuse them. Then what they will do, they will go to GitHub or somewhere. They will try to get some open source kind of software. They'll try to customize it, and they'll try, but they will not learn anything out of that exercise, right? So that's the one part I wanted to discuss. Now, suppose this hurdle you have passed, right? The way video game works, right? You have passed the level 1, right? What should be your level 2, right? First question you should ask is, just now I have written a program. What it is doing, it is able to do the job that I wanted it to do, right? Now be critical. Think about how much time it is going to take on my machine, right? Suppose if you have say billions of, say 1 million lines in your code, or 1 million book names, for example, right? You have written a program to find a particular book name in the list of those 1 million book name entries, right? One way is to write a linear program, right? You started with a single line and you iterated over for across all the lines, and you found that, yeah, there is a match. You written strcmp kind of function, you found a match, right? Your program will work fine. Definitely it will work fine. Now think about from 1 million scale to 100 million scale. Now try to benchmark that piece. How much time your program is taking? You can simply put those debuggers in your program and see like how much this routine is actually, how much time it is taking, right? Now, the second part is, here comes the concept of algorithmic thinking, right? Can we do it better, right? Can we search for a particular piece of information in sublinear time, right? Suppose 1 million entries are there, right? Now, one obvious approach is you sort all the entries, right? If you have sorted all the entries, then you can search for a particular key in only 16 only in 16 steps, right? It's only 16 steps. You can guarantee that whether the searched keyword is there in the list or not, right? Earlier, what you were doing in the worst case, you were executing 1 million lines one by one, one. For every line, you are doing a string comparison, right? Which is not a scalable solution, right? If you talk about Google search, right? So if you think like how if Google would have designed their search system using linear search strategy, then think how much time it will take to render a search page, right? You have just written Sarda University. The page is there in 0.005 millisecond, right? If they would have written all the information and they would have not have thought about algorithmically, so what would have been your time complexity, right? It would have been months, right? There are gazillions of documents are there in the Google servers. So definitely there is something which is not just doing their job. So you have to be algorithmically efficient. That's where there are a lot of buzzwords in the around, right? People people ask questions like why Google or why Microsoft is asking too much data structure and algorithm questions, right? People are not like when I'm hired, nobody is working on algorithms. That's not the case. You can't survive without having a algorithmic thinking. The simple example I gave you, right? In the similar fashion, talk about people are say ad tech. That's also a niche industry. What exactly is happening there? When you are just turn on your mobile phone, you start getting a lot of video ads, right? So the technology behind video ads is also very compelling, right? That's a very much algorithmic complexity there. Like for one request to complete, there are only 350 milliseconds. If you took more than 350 milliseconds, that request will time out and you will lose money. So software can make you earn money. Software can make a bad software can make you lose money also, right? So think about algorithms, right? So here comes the program speed. That's what I talked about. So next time when you study about algorithm, what do you have to do? You think like, why I am learning this? What the hell is all this buzz about? Why people are so much peculiar about learning algorithms? Why so many bets are there in algorithm paper? Go and download IIT Kanpur or say IIT Chennai's algorithm papers, like semester papers. You'll understand. So from teaching community, what I would suggest, not only ask students to study the previous year's question papers because UPTU's question papers are very repetitive. I don't know whether they are asking matrix multiplication this time these days or not. Earlier, they were asking in every semester paper, they were asking matrix multiplication. So think critically, right? Whether the approach I'm taking to engage the students, to teach them is right or not. Once out of interest, I downloaded IIT Kanpur's paper, like algorithms paper. That was very difficult. They have given unsolved problems of Cormand and Iskina, and there are a lot of books, algorithmic books, right? So that's how the critical thinking and algorithmic thinking can come into picture, right? So here I talked about scale in terms of program speed, right? Now you became a very mature engineer. You can write a program in linear time complexity or say constant time complexity, right? Now you can say in the assembly line, you have passed stage two also. Like stage one is start small. Stage two is your algorithmic thinking and data structure. So I hope I am able to convey the importance of algorithm and data structure to everyone,
Sure,
right?
sir, definitely.
Now, here comes, so entire planet is not about writing a factorial routine, right? It's like building a software, building operating system, building a CRM software, building Google, right? So it's not a job of one person or building Linux. Linux is, for a surprise, Linux is made and developed by one person only. I don't know how much truth is there behind that claim, but still. So, so scale is not only a program's scale, scale is also about a development speed also. How fast you can develop your code, how fast you can build your system. That's where all the software engineering principles will come into play, right? We have been taught about waterfall model, agile model, right? So nothing is, you can say, a magic, or say just all of a sudden something clicked, right? It's that some of the computer science problems are not addressable by waterfall model. That is why they went ahead and opted for agile model. And fortunately, the team I am part of is following both, right? During the plan, there is a detailed planning, because what waterfall model says that you start from I forgot the exact steps, but still there is a stage 1, 2, 3, 4, 5, 6, 7. You complete stage 1, then you go to stage 2, then stage 3, then stage 4. The challenge here is, if you found a error, a problem in the stage 7, then you have to do a rework. That is a costly affair. In your company, 10,000 developers are there. You are burning millions of dollars just to pay the salary, right? Just to pay the salary. Because for the software industry, the tangible asset is a employee only. It's not like a hardware industry. It's not like a cement industry. The tangible asset is an employee only who is able to write a code, right? Now the point is, so there, that's where waterfall, agile, and these practices come into picture, right? Now I'm going to emphasize about development speed. How development speed will become how you can increase your development speed, or how a typical organization is addressing the development speed needs is, that's where Git and lot of versioning tools and lot of collaborative code writing tools have been actually introduced. So your single program, your small program, then your optimized program, then you have to write these small units and build a big system, right? With a big set of developers, with say 100 developers. So 100 people cannot wait each other, right? So you write this, I will write this. It's not like this. It's a common tree where everybody is committing their code. Now, from development, so Git and other lot of versioning tools are there. I will not discuss about them, but I'm just telling you the importance of that. So you have been committing your code in a async manner. One person is committed today, one person is committing tomorrow, one person is committing day after, or say there are 50% who are committing on the same day, right? How will you address this challenge? Definitely a proper versioning system and CI/CD. That's a CI/CD is also a very fancy term. What exactly it is, I will explain very briefly. Is you have committed your code, automatically your test cases integration test starts running on your committed code base, and before going into production, you cannot commit your code. Your code cannot be merged to your master branch or your stable branch till the point your all the test case are passing. All the latency scenarios you have addressed, like you have added a feature, now your operating system boot up time has increased, right? That feature will not go, and it should not go, right? If your Windows operating system, you have clicked on the button and it turns up in say 1 minute approximately, right? If it started taking say 5 minutes, what will you do? That's good for nothing feature, right? So that's where CI/CD comes into play. Whatever you will commit, everything will be tested, like what exactly the implications of that, right? So that where your development speed and deployment speed comes into picture, right? Three things I've addressed. The last thing I wanted to discuss about is the scale of your system, right? When Amazon was built, or say when Uber was built, right? Let's talk about Uber. When Uber was built, they have built it for say the first prototype. Suppose it's the first prototype. How many users you can expect, right? 10 users. Your system is working fine. There are only 10 concurrent users for your system. You have deployed your code onto server. That those are very big, humongous machines with say terabytes of disk and RAM. There are 100 developers, sorry, 100 users accessing that system, versus your system became very popular, right? People started liking your system, Uber or say Amazon, right? Or say Flipkart also. Now you started getting millions of requests a second. The problem is not same. Earlier, the problem was just to run your system, do everything correctly, right? You bought a product from Amazon, the product list should come properly, When you selected one product, you clicked on that product, the payment gateway should perform properly. Those transactions should be atomic. Then it is submitted to a next queue of fulfillment team, right? Who is responsible for taking your product from the source location to your destination location, right? These are on a high level, there are 5 different areas, right? For 100 users, 100 concurrent users, the problem is still that is a problem, but it is not that much. But on a big billion day sale, suppose you just launched you just started publishing that tomorrow is my big billion day, everything I will sell for 50% discount, no matter how costly it is. What traffic you are expecting on Amazon system or the Flipkart system? Or let's take a Desi example. The Desi example is our IRCTC system, right? In the morning, like earlier, I have been a regular IRCTC user since it was introduced. Like when they just introduced, like you can book your ticket online. I have been using IRCTC since then. The most common scenario or the most common wallpaper on everybody's machine is this page cannot be displayed, right? What exactly it is? So think about the scale, right? They created a system, it was working for 100 concurrent users. But at the one fine day, at one fine time, when there are millions of users, your system is down, right? That's where the scale will come into picture. So, and that is, by the way, that is also part of curriculum, like distributed system, those Lampert cycles, and those lot of fancy things that are still being taught, right? So everything is relevant. What I mean to say, every subject, every syllabus is relevant, right? So think about a scale. So your solution of computing factorial, or your solution was simply there are some state machines. So state machine, by the way, I'm just name it because there is a subject named automata. People don't take it seriously, but a state machine is something that is there everywhere. People are talking about a state machine, right? So your state machine says that you just there is a list of products, you ordered a product, the state machine went into final state where the fulfillment team has picked the product, right? Now think like what I need to do to make the system work for say a million users. So there are different algorithms for that, right? It's not like vertical scaling can do wonders, right? Earlier that was the philosophy, right? If my system is down, my server is down, people used to say that it's only 8 GB RAM you are using, that's why it is down. Then they upgraded that to 32 GB. Nowadays, you can easily get a. I had that laptop. Right now, I don't have that, which is having 64 GB RAM in laptop. The first desktop I had has a. If I remember roughly, it's only 512 MB of RAM. So that is a. There is a law also. I don't know that law, Moore's law or something. That every 18 months, your for the similar price, your storage will get doubled, and your processing capacity will also doubled, right? So that's how the system is, right? So even if you increase your single machine's RAM by say 6-fold or 8-fold, you will not be able to address that thing, right? So there is you have to go horizontal, right? There should be horizontal scaling. So if one machine is capable of addressing say 500 requests, then route only 500 requests to that machine. Think around that topology, how you can address millions of requests in 1 second, right? How can you maintain state? And of course, how you can store the information, right? So MySQL is not a solution to everything. MySQL is a transactional solution, but it is having a lot of extra features which you don't require for such kind of information, right? So that is where transactional databases came into picture. That's where from relational to non-relational databases came into picture. MongoDB, Aerospike. So some of the things are optimized for write operations. Some of the things are optimized for read operations. Some of the things are very much you can say locking first kind of primitives. The way like MySQL work, relational model, maintaining the referential integrity, foreign key constants, right? So you have to put all those tools into your arsenal before going ahead and designing a big distributed system. So take all your subjects, all your books very seriously, because everything you are going to use in your professional career, in case you don't want to change your career, right? So from this concurrent setup, right? Then just to I'm just to cite an example that I'm not just telling something for the sake of telling. Think how you book your Uber. Think critically. I would request everybody to think on those lines. Don't just book Uber. Don't just order from Amazon. Don't just open your laptop. Everybody understands about the importance of operating system. Think what are the things are running behind the scene, right? You booked your Uber. Uber is not a magician. He's not God. Your location, right? Your client, that client that is installed on your phone, is sending your location to Uber. Your driver's location, which is always changing, right? Driver's location is not static. Your profile is static. You are Ajit, you are Arun, you are anybody. That information is static, but your location is not static. So there are two different needs, right? One database cannot serve everything. So what you have to think, for this kind of information that I want to persist, I will use relational database. That Ajit is father of someone, or Ajit is related to someone. That's the dependency. In case I want to transfer some of the credit points to his relation, that's a relationship, right? That's a different need. But your location is a different need. So you have to find a database of your choice, which is write heavy, which is designed for write heavy loads. So there are databases. Cassandra is a kind of database which is optimized for write heavy workloads, right? So that's what I would like. I think I have. I don't know whether I have explained too much or too less. I'm not sure. But the point is, I want to just tell: don't use a system. Everything is written by people like us. Just think how they have written. What are the design flaws? You order from Swiggy, right? Think sometime one fine day people book a Swiggy and they say that even in my household, in my house also, my wife keeps on telling me why this restaurant is not visible. So yesterday we ordered food. Why today it is not visible? I used to tell her like this is how it is happening. That restaurant partner who is a registered merchant with Swiggy has not onboarded himself. He has not logged into that machine. When he will log into that machine, his information will be conveyed using REST APIs to Swiggy's endpoint. That I am Haldiram, now I'm online. I have these many menus. There are checkboxes he can tick, and all the information will go in a JSON to Swiggy's backend, and they will start rendering that page onto your mobile, right? So Swiggy is also a very fancy example to understand distributed system. What are the things that are that a distributed system should have actually? So that's what I do. Though I work for, to give a little bit about my background, I work for a Windows operating system. So I don't have anything to do with Swiggy or say Uber. But yes, if I take a step back, then definitely I have to do something, right? What exactly is Swiggy? Swiggy is an app that is installed on my iPhone or say my Android phone or my Windows phone, whatever phone I have. It is requesting some of the resources from the operating system, right? Okay, someone has opened, I have to display that window, right? Who will display that window? In operating system, a single pixel, whatever it is coming on this laptop, is rendered by operating system, right? Think on those lines. Think on those from those perspective. I request everybody, be it a student, be our fellow colleagues or our respected teachers, PhD students, try to analyze critically, right? So that's I mentioned about object-oriented design also. Let's some last few words about object-oriented design, why that is required, so that when you go from this session, some of the things should stick to your brain, right? Two things I talked about majorly. Three things: start small, think algorithmically, think about scale, development speed, CI/CD, and the last thing I would like to discuss about is I forgot what I said just. I
CICD, sir. Swiggy you were talking about. Object
Swiggy.
oriented, you
Object
object
oriented,
oriented.
correct. Yeah, sorry about that. Object oriented design. So object oriented, you should study sincerely and religiously, because object oriented philosophy will will enable you to write reusable software components. It's not like every day we are writing code for, say, device driver. It's a reusable piece of code that everybody is extending, right? That's where you can reduce some development cycles. That's where you can optimize your development time also. So there are a lot of books. I think everybody knows them. They are very much publicly available. So few of them I like most is the Coreman's book for algorithms. There is a head first design pattern book for object oriented analysis and design. And there are a lot of literature. Even if you're not a good book reader, book reading guy, you can go on internet and find your own. A lot of YouTube videos also, right? So I think these are the set of things that I wanted to talk about. So if anybody has any questions, any feedback, let me know. I would
Thank
like
you.
to.
Thank you so much, Ajiji. You have very beautifully addressed not only the basic concepts, but the complex concepts also, without making them complex. So we have a question from Megha Joshi here. So can you explain how we can relate automata machine with today's real-time example? Automata machine she's interested in. However, you have thrown some light in the past also how we can relate automata, but if you could give an expert comment on this.
Definitely, and it is a very good question actually. So you think about automata. So let me take a step back. What automata is, right? Automata is finite state machines, push down automata, and Turing machines, right? And thanks for asking this question because it is like a nostalgia when I'm thinking about these state machines and all, right? So if you think anything is a state machine, right? If I just shut down this window, there is again a state machine will come into picture. What happened? There are two branches. Whether this machine is shut down because of the power loss or the user has willingly done that, right? That is the state machine. And if in every state, you have to take a decision. What is the final state? Final state says that, yeah, I am in a comfortable state. It's not an abrupt shutdown. Even if it is an abrupt shutdown, there is a different state machine. So a state machine is nothing but a set of decision points where you are. Like if I turn on my AC and if I try to provision it like at this point in time, the temperature should increase by this much, like 1 degree every hour. Like I should not be shivering in the night. So that is also a state machine. This is because I just saw the AC running. So that's the only example came into my mind. So everything is a state machine in the programming terminology. Every if else, whenever you see a if block in your code, that is a state machine. If yes, you will go to this state. If not, you will go to this state, right? In autonomous cars also, that's also a state machine. You entered in the car, you pressed which button, you are pressing the pedal, you are pressing the something or something. So these are very high level ideas. But in networking terminology also, there are a lot people program for state machines. Like in this state, what are the things I have to do, right? Suppose there are, you can say, a publisher subscriber routine, right? Suppose you booked your ticket from IRCTC or say from Make My Trip. You have configured that all the notifications should come to you in your email, on your mobile phone, or a lot of things, communication mechanism, right? So that is also a state machine. So when your automata transitioned from not booked to booked, that is one of an intermediate state. And after that, you took three different branches, right? Those are the final states. If you have sent it to from mobile, from to your email box, so that is what is the importance of state machine. And without a state machine, by the way, you can't program anything. Different milestones in your software system are also state machines, right? From this state machine, I will take this decision. So in your life also, your life is also a state machine with no final state. So it's the final state which you can't actually give a feedback to, right? In your life, in all the intermediate states, you can give feedback. Ah, this should be done like this. It should be done like that. But the final state, you can't give feedback because you're not there, right? So I hope I answered your question.
Yeah, so we have another question from Mr. J. Abdul.
Hmm.
Yeah, he wants to ask how automated machines are connected to microservices,
Automated machines.
or might be automata, it might be a typo.
Okay.
He has written how automate. So
Okay.
I
Let
thought,
let me let me because since the it is contextual to automata only,
yeah,
so that is the I would take it as an automata only.
yes,
Okay.
yes,
So what is microservices? I would tell you basically to just for the audience who is not very aware of the microservices patterns, right? There are two different software paradigms. One is monolithic architecture, where you are writing everything as a single program and releasing as a single program. Mostly operating systems are written like that, right? If you talk about microservice, I gave example of Uber, where there are a lot of microservices running into picture. One is a discovery service, right? One is a booking service. The discovery means you are where are you actually, and where are the potential cab drivers. One is payment service, right? One is a big data service. So there are different five, six different services, and they are, you can say, a good object-oriented terminology is a highly cohesive and loosely coupled architecture. Highly cohesive means a one module which is capable of performing that job diligently, and it is not responsible for doing anything else. Like you cannot query payment module to provide you driver's location, right? That is the example of bad design, right? Now, to answer Mr. Abdul's question, right? Now, suppose you have booked your cab or you have done the payment or something. Now, let me tell you the state machine system here. There are queues, right? There is a queuing pattern also. What you can do, not everything has to be done synchronously, right? I can call to you anybody, that is a synchronous communication. I can send you a WhatsApp message, that is a asynchronous communication, where you will see it when you are free. So what is that? The second one is good, right? If you don't have any pressing concern, like someone has swiped your card, that is a very much you can say a very much pressing need, right? That's a high priority task, right? So you should be informed immediately. But after your completion of your trip, right? You have completed your Uber trip or you have ordered your food, right? Then there are different state machines. You have ordered your food, your payment is done. Like everything is from one microservice to another microservice. This is getting transitioned. One service is calling another. Now, suppose when you have ordered something, you have written to that. There is a queue also. You have written to queue on which there are multiple microservices have subscribed to, right? So notification service, email service, and lot of services are there, right? So if you take, as I explained previously also, right? You cannot do everything in one go. In case of restaurant booking also, in case of food delivery also, right? You cannot simply start tracking a delivery boy because there is no delivery boy assigned to you, right? Just looking for a delivery boy or drive delivery boy's location service, you have to pass certain stages, right? So those were your intermediate stages, right? When your delivery is complete, then that is the final state. And even in the final state also, in your context, it is a final state, but you have pushed some of the information in the queue to be consumed later, right? What happens? Your delivery is done. There is a message that is sent to a queue. Queue is basically an asynchronous way of communicating, right? The message is sent to queue. All the subscribers of that queue will understand, oh, there is something has come. Now what I have to do? I have to send the customer a feedback form. Are you satisfied with the user, with the delivery, taste of food? So that is one state. And another service, what it will do, it will send a feedback form to delivery boy also. How was your experience? Was the person who has ordered the food was rude? So, and then what happens? If the information is collected, that information will be flown to big data pipeline, right? The big data pipeline has a lot of routines. Those will analyze millions of orders daily and start putting every user and a driver and a restaurant into a certain bucket. And after say millions of transactions, they will start flagging this that the rating of this restaurant is less. You may like this, you may like that. That's where the recommender system will come into picture. So basically, in microservices architecture, the final state machine is contextual. Like this is job of my microservice. I am a payment microservice. Payment is done. If the payment is not fraud, I have received the payment, then my job is done. I will push this information to a queue or directly call a microservice, then that state machine will come into picture, right? So there are a lot of examples. You can think about a chain of responsibility pattern also. What it's a very much known object-oriented design pattern, chain of responsibility pattern. You did your job, you push to something else. You did your job, you push to something else. That's the chain of responsibility. Where in microservices, it's not like one microservice is calling another. You can do in async manner also. You can put your information in a queue, and whenever that person is ready to pick that job, he will make a blocking poll to your queue and pick that job. That's it. So from this blocking poll, one thing I got remembered, but you go and take it as a homework and understand the concurrency scenarios also. Like what is blocking poll, what is non-blocking poll, how it is important. If you think critically, you will understand, yeah, this is very important. Two person are trying to book the same train ticket, right? How will railway ensure that the ticket is booked to only one guy, not two guys, right? So think on those lines. Take it as a homework if you understood what I tried to explain clearly. Or I hope I have answered your question, sir.
Definitely, sir. We have another query
Hmm.
from Dr. Nitin. What type of high performance computing architectures are used in Microsoft especially? High
Good,
performance computing architectures.
good question. This is a very good question, I would say. So I would say that consider, and you must have known that Microsoft Bing is a Microsoft product, right? So Bing is also or and Azure, so everybody knows, right? So Azure is all about high performance and everything. Because if Azure is not high performant, AWS would have eaten it, right? Right now, Azure is, I think, white horse, right? Now, what I would like to answer your question, right? How can you build a search system, right? I've been fortunate enough to be a part of a big high performance search system, right? What we used to do is we provide a search service for code, right? Suppose you are Amazon, you have billions of files and billions of code lines, right? You want to search that. I want to search for this routine, which says that connect to Kafka. That's the only thing I want to search, right? In trillions of documents with petabytes of data, how can I get the information quickly? Where is that routine kept? I hope you will consider that as a very high performance search infrastructure. How we made it possible? Because we don't have a SLA of say 15 minutes. You take 15 minutes and return to me with the answers. That's not the case. We have to be very performant. How we did that? We build indexes. If you study Corman, there is one chapter. They talked about inverted indexes. So inverted indexes are very simple. They are like hello world, but they are used across the board everywhere. If anybody is talking about search, they are using inverted indexes. Be it Amazon for product discovery, be Flipkart for product discovery, Microsoft, Google, everybody is using inverted indexes for code searches. For us, what we did, I will cut short this description, but I hope I will try to explain your question like following, like in the on those lines. I'm just trying to rephrase like how I can communicate this thing. Okay, so think this way. You have committed your code base, right? You want to make it searchable immediately. What will you do? What we did, if you have committed your code right now, you will be able to search your code results within next 15 minutes. And after that, whatever you want to search will be returned to you in 1 millisecond only, right? So to build a very, very high performance search infra, you need three different pieces, heavy duty pieces. One is crawler and one is indexer. So crawler are very much compute heavy machines. What happens there? When you have submitted say millions of documents as your code file, suppose you are Linux towards you have committed Linux, right? And there are millions of files. You wanted to make your code searchable. What will you do? You will commit your code onto our platform. Then our heavy duty crawlers will parse every file into your code base, every line, and they will build an inverted index saying that if you call about Kafka word, or say distributed word, I will search for only those files who have distributed written there, right? That is what is inverted index. It's not like you are going file by file to look for that word. You are going to only those files who are having that word, and you will build an index out of that. That is why it is called inverted index. Why it is high performant? Because you can add as many crawlers as you want. Like if the three crawlers are not sufficient to do your job in a limited SLA, you can add 30 crawlers. That's the power of distributed system, what I was discussing earlier. You can even add 100 crawlers also if the SLA is even lesser. And it is very elastic in nature, how many crawlers, how many feeders you want to have. So definitely, if you think about any searching system, be it a Google search, be it a Bing search, be it our code search, everything is highly performant. And the only thing is you have to break down the problem into multiple sub problems. That's how you will be able to build multiple microservices, and you will be able to scale them individually. That's what the end goal is. Like you can divide your development team also on those lines, saying that, Bhaiya, I am the I am the master of crawling side. I am the master of indexing side. He is the master of querying side. So any problem that is related to query or any feature that is related to query side, he will address. Any service that is related to this indexing, I will address. And on top of that, a monitoring infra. Monitoring infra means your system should be always available. I can guarantee that in entire lifetime, you have not seen you have written something on Google and it has written that the page is not available. That is what is high availability. This is what people call about 5 nines of availability. 5 nines of availability means 99.999 times available. It's like in 1 year, your system is down for only 3 minutes. Or like it's a very, like, I don't know the exact number, but it's a 3 minute downtime. See, the billions of documents, petabytes of data, billions of users, and you are down for only 3 minutes in your entire year, or say 5 year or 3 year. That is what the power of availability. So there is separate teams also. So any high performance computing infra which is having a stake like Microsoft or say Google, they have to create a monitoring layer also. So I hope I have addressed your question, Dr. Nitin.
Yes, sir. Yes, sir. So, any other query from any of the participants? As I can see many of appreciation messages in the chat window that this was a very informative session with very nice information. So, anyone having any other query, you can ask, you can write in the chat window. We are open for question answer session right now. Anybody having any question? I think we don't have any more questions now. So good session. Thank you. Again, we are having appreciation messages only. So Ajit ji, I request you to kindly unshare your screen first so that we can go into the gallery view. And I would request all the participants if they could switch on their video so that we could have a good screenshot.
I hope I have not bored you guys.
No, definitely not, sir. Anyone, if he or she would like to share his or experience or feedback on this session, I may allow you to unmute yourself. You can just raise your hand and we will allow you to unmute yourself if you want to say something. Dr. Nitin, may I request you? Dr. Nitin is a very sincere attendee of this FDP, not of this FDP only. He is with us throughout all the FDPs we have conducted so far.
Sir, we have a heads up, I guess.
Yeah, thank you, sir, for your nice session. And it was very important from the point of not only faculty but UG/PG students. So how they should develop their career and how the coding is important, how they should think in terms of scalability. And as you said, response time or program speed is also very important. And you answered my question very nicely about the high performance computing architecture. So uh, you have given a lot of very good guidelines, so that uh, these guidelines will be very helpful for not only the faculty who is joining this FDB, but along with them UG, PG as well as PhD students also, because when they will join the industry, so how they should build their career uh, uh, on the base which they have created while doing their bachelor's, master's, or PhD. So that will be very helpful. And as this FDP has a mix of sessions from academic, not only from industry persons like Microsoft, as well as from uh, other industry persons, as well as today there was one session on quantum cryptography from one of the scientists working in the Ministry of Electronics and Information Technology. So this FDB is giving a lot of good scope for learning. So now it's our duty to pass what we are learning in this FDB to our students, as well as research scholars, as well as
Yeah,
our colleagues.
definitely, sir. It will be great for it. It was great for me also to discuss with like such a great audience. So everybody is, I think, a lot senior to me. But yeah, it was very like engaging discussion for me as well.
Yeah,
We have
thank you, sir.
also with us Dr. Godfrey. He is also attending all the sessions very sincerely. Dr. Godfrey, would you like to say something?
Thank you. Thank you so much for the opportunity. It's most appreciated. What I would say is the previous speaker really, touched on critical areas that are happening practically in industry currently. And just give an overall comment about this whole program, the session, the advanced, really, I want to give appreciation to the organizers for a very, educative, and the selection of the speakers was very good, because, they were touching on areas that are happening in the industry: information technology, computer science, machine learning, artificial intelligence, cryptocurrency. It was very educative. You could see by my attendance that, and I'm actually sitting in Africa. You are 3.5 hours ahead. So by when it's 10 o'clock there, it's 6 o'clock here. But I really made sure that I could attend, so that I get to appreciate the program. Thank you so much for the opportunity. It is most appreciated. And I hope we will get more of these sessions in our department, in the computer science department, to educate us, especially the PhD areas. And these participants, the speakers, maybe could even offer us, in their respective areas of work, areas to help PhD students in their fields. Thank you so much. It's most appreciated.
Yeah, thank you, sir.
Thank you, Dr. Godfrey, and thank you, Mr. Rajit. Thank you for being there. I think we have Mosmi Goswami also with us. Mosmi, would you like to say something?
Yes, sir. Sir, I'm really grateful to our speaker, and the session was really wonderful, and especially the strategy. This is something which is generally not discussed. What should be the strategy when we teach, or every day? We know that in computer science and engineering, we are learning every day. And we are also encouraging students that you learn every day. But sometimes we miss to give them the correct strategy. So I really love the way you actually linked the supply and the demand, point one, and point two, time, how important it is to grab the correct opportunity and to understand what would be required and to create a strategy in the correct path. So I'm really thankful, because the session was not only to cover the content, but also to give to how to acquire the skills based on requirement to meet the requirements of the market and to gain the most. Thank you very much. I'm really grateful to the organizers who has brought actually our resource person of the day, and really thankful to the expert speaker as well as the organizer. Thank you very much.
Thank you, Mausumiji. Thank you so much for your appreciation given to the speaker as well as to the organizing committee. And we will take care of in future also, so that we are able to invite learned guests so that they can share their expertise with the audience, and that can be forwarded to the students also. And thank you, Ajitji. Thank you once again. Thank you for
You're welcome, sir.
sharing your valuable time, and so that you could address the gathering here. And definitely the knowledge that you have conveyed will be carried forwarded to the students, so that they can also become a successful person in their life. Thank you very much. Thank you once again. And I would like to request Dr. Bhupendra Dwivedi also, if he want to say something. Sir, kindly unmute yourself. Dwivedi, you want to say something? Yes, you are unmuted now.
Actually, this is a very nice session and we have learned a lot. Actually, we know something, and we are also having some keywords here to know about the algorithm also. In algorithm, there are inverted index, I don't know actually. So this is what
In
we
fact, I am fortunate enough that I am a student of Ajit Tripathi in case of design and analysis of algorithm.
I am teaching algorithm for a long time, but I am not know this keyword about the inverted index that is in Coreman. So these are the knowledge we have get here, and we have enjoyed, and he is very knowledgeable person. So the session was very good, and thank you and thank you, Mr. Ajit.
Welcome, sir.
Thank you so much. Thank you, Ajit ji. Thank you for being there. And we have shared the feedback link in the chat window, so participants are requested to kindly fill the feedback form. And as far as tomorrow's session is concerned, we have Mr. Gautam Shrivastava, who is from Brandon University, Canada. And his session will be a bit early because he'll be in his 24th night only, because Canada is around 11 and a half years behind India. So tomorrow's session is going to start a bit early at 9 a.m. IST. So I request all the participants to join us in time, so that speaker doesn't need to wait. Thank you, everyone. Thank you once again for your patient listening and being attentive throughout the session and asking questions to the speaker, so that they also feel good that people are attentive. Thank you, Ajit. Thank you once again. Thank you, all the participants. The session will remain live for another 5 minutes, so you can fill the feedback. Thank you, Ajit. Thank you.
Bye-bye. Bye, sir.
Yeah, bye, sir.